So ChatGPT 5.6 Terra and Google Gemini 3.6 are going head to head right now, and the gap is real. On agentic coding, Terra's proxy model hit 67% on Deep SWE version 1.1 versus Gemini's 49%, which is an 18-point difference. Both models just dropped, and developers are already picking sides. So I ran them through 4 real tests: reasoning, latency, pricing, and context. Every figure traces to a source, no vendor talking points, no made-up numbers. And honestly, if you're running high-volume agentic workflows, the pricing gap between these two could eat into your budget in ways the headline numbers don't warn you about. Which one actually costs less at scale? That answer isn't as clean as you think. So who's this for? Developers, teams, anyone paying per token at scale. If you're running agentic loops, building coding tools, or just trying to figure out which model gives you more for your money right now, this comparison is for you, because picking the wrong one costs real money every single month. Test 1 is multi-step reasoning accuracy. You guys know the pain here. You give a model a complex task, it gets 3 steps in, then it just starts hallucinating or looping, and you lose an hour debugging something the model confidently got wrong. That failure mode is exactly what SWE Bench and Deep SWE are designed to catch. Okay, so what I looked at here were 2 benchmarks from a community blog on SWE Bench Pro. Terra's proxy model came in at 62.7% versus Gemini's 58.7%. And on Deep SWE version 1.1, it's 67% versus 49%. What surprised me was how wide that second gap is. And both figures come from one block source, not independent testing. So keep that in mind. Now, I want to be honest before we call this. Both scores come from the same community blog, not from OpenAI or Google's own pages. And the MLE bench number only has a Gemini figure at 63.9% with nothing from Terra to compare it to. So treat these margins as directional, not definitive. The gap is real, but it's not airtight. ChatGPT 5.6 Terra takes this one. I was expecting a close call, and on SWE bench, it kind of is at just 4 points. But the Deep SWE result is way more lopsided than I anticipated at 67% to 49%. And that's hard to ignore even with the blog source caveat. Terra goes up 1-0 on the scoreboard. Test 2 is response latency under real-world load, and this one hits different when you're literally hammering a model in an agentic loop. A slow response tax, you're paying for idle compute time, your pipeline slows down, and the whole workflow takes twice as long as you planned. What surprised me here is that I was expecting at least one hard number, and there just isn't one. Neither model has a published MS per token or tokens per second figure in any source data, though Gemini 3.6 Flash does have one real data point, generates 17% fewer output tokens per completed task compared to its predecessor, which is a genuine efficiency gain in agentic loops. Okay, so the honest read is this, that 17% token reduction on Gemini's side is real progress, but it's a comparison against Gemini's own prior version, not against Terra, and Terra has 0 sourced latency data at all. I can't tell you which one is faster because the numbers simply don't exist yet in any verified form. This one's a tie, and honestly, I didn't see that coming. I figured at least one of these models would have real latency data published somewhere, but neither does, so you can't pick a winner when there's nothing to compare. And the scoreboard stays at Terra 1, Gemini 0, with 1 test tied. Test 3 is pricing per token at scale, and this is the one that sneaks up on you. You run a few tests, everything feels fine, then you get your bill at the end of the month and realize you've been paying a premium you never consciously chose, because at high volume, $1 or 2 per million tokens is not a rounding error. So I looked at the community reported rates, and here's what we got. Terra's proxy model is $1 per million input tokens versus Gemini's $1.50. And on the output side, it's $6 per million for Terra versus $7.50 for Gemini. Both figures are from one block source, not vendor pricing pages, so take it with a grain of salt, but the direction is clear. Now, this is where it gets a little interesting. Gemini 3.6 Flash's 17% token efficiency gain over its predecessor partially closes that cost gap in practice. So if you're running long agentic loops, Gemini might end up cheaper per completed task than the raw per token rates suggest. The headline numbers favor Terra, but the real world cost picture is honestly closer. On raw per token pricing, Terra wins this one. I was expecting pricing to be pretty close, but $1 versus $1.50 on input and $6 versus $7.50 on output is a real gap even from a single block source. So the scoreboard moves to Terra 2, Gemini 0. 1 tie. And the efficiency nuance is real, but the headline rates still go to Terra. Test 4 is context window and memory retention, and the failure mode here is super specific and super frustrating. You're mid-session on a long document task, the model starts forgetting earlier context, and it gives you an answer that contradicts what it said 20 messages ago, and you don't always catch it, which is the scary part. Honestly, what surprised me here is that I found basically nothing concrete for either model. No token count for context window size, no measured retention score. Gemini 3.6 Flash has some qualitative claims about improved long horizon understanding, and it's got documented enterprise deployments at Harvey and Hebbia for document parsing, but there's no hard number to put on screen. And look, the Gemini side does have something Terra doesn't: real enterprise receipts. Harvey and Hebbia are using it for long context document work right now, which Terra can't match on sourced evidence. And I think that counts for something, even though it's qualitative and not quantified. So Gemini has a soft edge here, but I honestly can't call it a clean win. This one's a tie too. And I'll be honest, I was expecting Gemini to edge it out given those enterprise deployments, but without actual token counts or retention scores, I can't hand them the point. So we finish at Terra 2, Gemini 0, 2 tests tied, and the context question is genuinely unresolved for both models right now. But where does ChatGPT 5.6 Terra clearly win? 3 things. It scores 62.7% on Sui Bench Pro versus Gemini's 58.7%. A real 4-point gap on software engineering tasks, and the deep Sui lead is way bigger at 67% to 49%. On top of that, it's cheaper on both inputs at $1 versus $1.50 per million, and output at $6 versus $7.50 per million. Now, where does Google Gemini 3.6 win? Its Flash variant generates 17% fewer output tokens per completed task compared to its predecessor, which compounds into real savings in long agentic loops. And it's got documented enterprise deployments at Harvey and Hebbia for long context document work that Terra simply can't match on sourced evidence. On MLE Bench, Gemini also scored 63.9% with no Terra figure to compare it to. Okay, so I was expecting this to be a tighter overall race, but the coding benchmarks really did break Terra's way. So here's the decision rule. If you're running high volume agentic coding workflows and raw reasoning scores plus lower per token costs are what you're optimizing for, go with ChatGPT 5.6 Terra. But if you're doing document-heavy enterprise work where long context retention and proven production deployments matter more, Gemini 3.6 is the one with the receipts.